Okay, today is our last lesson of the 8th grade curriculum, 8M7, lesson 23. Sorry, I can't put the nice words on the screen anymore. As I told you, Google took that ability away a couple days ago, so you're just gonna have to listen to me, but you'll see it on the screen when we go down to the notepad. So today what we're gonna do is we're gonna do the last lesson. I'm just gonna do the one straight out of the book because it's kind of a difficult one and I wanna make sure that you understand it, or at least I have a chance to try to explain it if you didn't understand it in class or if you missed class. This is neat because this is an application of math, and again, it uses all the building blocks that we've used throughout the entire school year. And you're really doing something very close to calculus here in 8th grade when you're doing this type of math. So it's fun. I love this stuff. This is great. Hopefully I do a good job of explaining this one to you. And let me know if I do. Thumbs up, subscribe, tell your friends, send me a note, whatever. Let's go. Let's do this thing. Okay, here we are. So the question here, and I'm going to try and show you a little bit of a video of this. What's happening is you have this ladder that's L, and it's slowly sliding down this wall at 1 foot per second. So it's moving down the wall at 1 foot per second. And then the question is the bottom of the ladder, how fast is that moving away from the wall? Is that moving at a constant rate? If this ladder is falling and you're pushing it down this wall at 1 foot per second, is the bottom of the ladder, which is touching the ground over here, moving away from the wall at 1 foot per second, or is it speeding up or slowing down? Now let me try and show you this a little bit more clearly. Let's go over to let's go over to this other screen for just a second and see if I can maybe explain this to you a little bit better. Okay, so we're now on this screen. Let's just pretend that this blue, this is our ladder here, and this is our wall. So, and let me see if I can articulate the question we're at. Hello, Mr. Owl. You're watching this very closely. Okay, let's see if I can explain this to you. So the ladder is going down the wall. And notice as the ladder goes down the wall at a certain rate, this piece down here is moving too. So this piece of the ladder is moving straight down. And we'll tell you what that rate is in a little bit. And as this moves down, this part of the ladder, notice this part of the ladder moves straight to the left. So it's kind of interesting. The ladder's kind of twisting. I mean, it's kind of twisting like this, if you will. As it comes down the wall, this piece is going straight down, and this piece here is going straight away from us, kind of this way, right? So the question is if this is coming down at 1 foot if this piece here is coming down at 1 foot per second, how fast is this piece going this way? Is it going at 1 foot per second also, or is it speeding up or slowing down? Okay, so that's the question. Hopefully that was a good image for you. Hello, Mr. Owl. And we'll just be we'll go back over to our sketch pad, and I'm going to try and draw. We're going to work on some of the math that's going to help us answer this question, because you can actually answer this question using what you know in 8th grade math. Let me just kind of get my desk set up for me so I can do this. Okay. Getting everything back to normal. Okay, so here's a picture of what's going on. Here's the ladder, kind of, and then it's slowly falling. As it falls, it goes like this, and then it goes like this, and then it goes like this. But we know, in this case, a ladder is a certain length. And we're going to, for sake of this exercise, we're going to say the ladder is 15 feet long, and that its velocity, its vertical velocity is 1 foot per second. So it's moving down the wall at 1 foot per second. So after it starts off at 15, and then after 1 second, it's at 14, and after 2 seconds, it's at 13. After 3 seconds, it's at 12, et cetera, et cetera, et cetera, until it's at the bottom here at 15 seconds. And the question is how fast is the bottom of the ladder moving that way? And our strategy is going to be the same as we used on the last lesson. We're just going to take intervals, figure out where it is at 0 seconds, where it is at 1 second, where it is at 2 seconds, etc. And then we're going to graph it, and then we're going to use our slope formula to make estimates about how fast it's moving. So again, let's now move on over to this picture. And we can see that near the start, and this is how we're going to figure out where it is on the bottom part of the ladder, where it is at any point in time. Notice near the start, we're 15. This whole piece here is about 15 feet. This hypotenuse is 15 feet. We're going to use our Pythagorean theorem, and then we can figure out how far away from the bottom of the, if you call this the origin, we'll call this point O, we can figure out how far this is by using our Pythagorean theorem, because this ladder is always 15 feet long. So notice, after 1 second, this is, it started at 15, but after 1 second, if the ladder is moving 1 foot per second this way, it's now 14 feet away because it's gone 1 foot in that 1 second. So if this is 14 feet and the ladder is 15 feet, then we can know after 1 second where the bottom of the ladder is by using our Pythagorean theorem and saying, well, 15 squared equals 14 squared plus b, b1 squared, if this is b, kind of like b1. Then after 10 seconds, we would know that the ladder is 5 feet from the ground because it's traveled 10 feet this way in 10 seconds. And we can figure out where the ladder is from the bottom, along the bottom, by using our Pythagorean theorem. Again, 15 squared equals 5 squared plus b double prime squared. And here, near the end at 14 seconds, we can say, well, our b triple prime, or that we could call it b3, is 15 squared equals 1 squared. Again, Pythagorean theorem plus b cubed squared, and that's our b3. So we can use this same formula to figure out where along the bottom of the ladder is at any point in time. So that's the strategy we're going to use. And then we're going to build out this chart. So notice, we know that A is going to move at 1 foot per second. So after 1 second, it's going to be we're going to find the distance from O. So it's 15 from O when we start, right? It's because the ladder is straight up and down. And the B distance is 0 from O because the ladder starts here. But after 1 second, we know that the ladder has fallen to 14 feet. It's at 14. This whole piece is 14. Because it's moving at a constant 1 foot per second down the ladder. Now we can find out what B prime is. How far is the ladder from the bottom? And we can know that, remember, because this is 14, this is B, and this is 15. So let's use that Pythagorean theorem to figure out what B prime is. So 15 squared equals 14 squared plus b squared. And if you solve that, you get 225 equals 196 plus b squared. B squared equals the square is equal to 29. So b equals the square root of 29. And that's equal to 5.3. I'll do one more, and then I'm going to let you fill out the rest of the chart. So let's do, we also know, well, let's do when we have 3 seconds. So after 3 seconds, this ladder's fallen 3 feet because it's moving 1 foot every second. So after 3 seconds, it's moved 3 feet. So this is 12. So we have 15 squared equals 12 squared plus b squared. 225 equals 144 plus b squared. B squared equals 81. So b equals 9. Well, that's neat. We have a 9. Because in this case, we have a 12, 15, 9 triangle, which this is a multiple of a 3, 4, 5 triangle, if you recall. Times 3, times 3, times 3. So that's a perfect, that's a perfect triangle. Okay, so I want you to keep working this. Notice that when you get down to the end, this should be 0, and this should be 15. Also notice that we should be able to calculate all these. After 4 seconds, this thing will be at 11. After 7, it'll be at 8. After 8, it will be at 7. And after 14, it will be at 1 foot. Because again, it's moving at a constant 1 foot per second. So after 15 seconds, it will have moved 15 feet. And so this will be 0, will be at the bottom. And the ladder will fall all the way to the bottom. And so the B distance should be 15. Right? Because if the ladder's all the way at the bottom, it's fallen to the ground. This top is here at 0, and the bottom is here at 15. So I'll let you fill out the rest of this chart. So, fill out the chart. And then we're going to, using this strategy, and then we're going to move along, and then we're going to graph it and figure out whether or not this ladder is moving at a constant rate, or if it speeds up, or if it slows down as the ladder falls. Okay, if you did it correctly, this is what you should get. You should get 5.3, 9, 10.2, 12.7, 13.3, 14.97, and 15. And so this is our time in seconds, and this is our distance along the bottom. Or the distance from the bottom of the ladder has moved. And so that distance is in feet. So you can kind of see what this curve is doing. And I want you to think about, as we move into the next, I want you to answer these questions for yourself. What are the units of slope? B, is slope increasing, constant, or decreasing? And see, what does that tell you about the answer to our question? And our question again is the bottom of the ladder speeding up, slowing down, or staying constant? Okay, and remember, to think about whether this is an increasing or decreasing slope, think about yourself. If you're walking up a mountain, is it getting easier, harder, what's going on as you move along this slope? Is it getting shallower or steeper? And that means, is it increasing or decreasing in steepness? Okay, I want you to pause, and then I'm going to switch cards. Answer these questions over here. Okay, now I assume you're back. Let's move on to the next slide. And this is our final slide. And we're going to answer these questions. So our slope, our units are, our y units over our x units. This is our slope units. And so that's our feet per second. And that is a speed. Feet per second, that's how fast you're moving. Now, the second question was, is it increasing or decreasing? Well, it's not constant, because constant, remember, it's not constant because it's not a straight line. And if there's one of the big things I want you to take away from this year is that constant slopes mean constant rates, and they're straight lines. So this is not a straight line. It is a steep line getting less steep. So our rate is decreasing. So that means C, our slope is decreasing. So that means our speed, which is our slope, our speed is decreasing. So it's getting slower and slower. The bottom of that ladder is moving fast, and then it starts to slow down. Starts fast, and then slows. And so let's estimate how fast. So this is the final thing that we're going to do. The final thing we're going to do is we're going to estimate our speed between 0 to 1, then between 7 to 8, and then 14 to 15. And we're going to do that to prove that it is slowing down. We can see it visually, but we want to prove it. So we're going to look at between 0 and 1, what our speed is. And that's basically this and this. We don't need this column. Between 7 and 8, right? B is our speed along the bottom, and then 14 and 15. So that's basically delta y over delta x. So our delta y at the beginning from 0 to 1 is 5.3 minus 0, and that's 5.3 feet per second. It's moving fast at the beginning. Delta y over delta x now from 7 to 8 is 13.3 minus 12.7 over 8 minus 7, which is equal to 0.6 over 1 feet per second. So that's 0.6 feet per second. And now let's look at the very end. We're at, delta y over delta x equals 15 minus 14.97 over 15 minus 14, which is equal to 0.03 over 1, which is equal to 0.03 feet per second, slowing down a lot. So it starts off fast. Halfway through from 7 and 8 seconds, it gets slower, and then it is really slow at the end. So let's happy cat, happy cow, happy cow. Let's do a happy cat. We like our happy cat. for this nonlinear motion exercise, which really exercised all of our math skills, or much of our math skills, our graphing skills, our slope calculation skills, our critical thinking skills, the Pythagorean theorem, all kind of stuff, really powerful stuff. And hopefully I've helped you build a good base going into high school, full-on algebra, and the rest of your high school math career. Let me know if you like this video series. I really would love to hear it from you, and it would help me to know also just what kinds of things I do well and what kinds of things are not helpful. Homework help, is that useful? The explanations, are they helpful? The extra examples, what is it that's helpful, and what would help you next year in math? Because I can do more of these, or I'm willing to change how I do this, because I'm really passionate about making math great for you, and I want to reach as many students as possible, which is why I do this online. So let me know, subscribe, thumbs up, thumbs down, comments, all of it's good. So happy cat, happy math. See you online.